Hello, hello.
Michael Herman here. Hi, Colton.
Hi, how's it going?
Good. You know my my chances of finding an actual meeting here are low, so I'm glad you're here. Do you think we'll have much of a turnout?
That is a good question. It's it always feels like I'm
Besides
rolling dice.
besides that Discord channel, is there another place where DIDComm conversations are going on?
The only two places that I know of are the DIDComm channel for the users group, and then there is the Slack channel for the working group.
Oh, okay. I'm not sure I belong to the Slack channel.
Normally, I like to wait 5 minutes after the hour to get started so that people can attend, but maybe that's a bad thing.
No,
Um,
no, it's fine.
Sometimes I wonder if it leads to slackers.
And yes, there are 323 slides in this deck, but it's my whiteboard. It's my living whiteboard.
I was gonna say, I mean, it kind of does look like a whiteboard too, with that
Yeah.
background you've chosen.
That background, that's just a PowerPoint background.
Right, I'm just saying it looks like a whiteboard.
Yeah. Or like a white wall going down to the floor.
Yep.
How come so few slides? Only 323?
No, I'm only using, well, this probably goes back about 3 years.
Yeah.
All kinds of stuff. But I don't know, it's just got into a, there's my sliced JSON slide.
Oh,
I
nice.
love it.
Hey, it's lunchtime here. It's making me hungry.
I
That's
like
a good looking
sourdoughs.
loaf. Yeah, a good looking loaf of bread there.
I think, yeah, this one is actually AI generated. If you look in the cracks, it's the same as this, And then I told, I forget if it was Chat GPT or Copilot, to slice the loaf into even pieces.
Yeah, I guess ChatGPT has never made a sandwich before.
Huh,
But I mean, it can certainly slice bread better than I can.
pretty even.
Yeah, I think it's a little too equal. I don't know. Got to have some rusticity in there when you're eating sourdough.
Yeah. I might have started with rye on that one. I forget.
Yeah.
Alrighty, welcome everyone to the first DIDComm user group meeting of the month of March 2026. Uh, I see familiar faces unless someone wants to reintroduce themselves at this time. But hearing nothing. Today, our topic of agenda is uniform DIDComm message types presented by Michael here. So, with that being said, I'll let you take it away.
Thanks, Colton. Um, so I've been doing this did stuff for quite a long time. I'm a named contributor to the original did spec um, and a bit of a rebel. Um, and so I picked kind of an innocuous name here, did call message types. I'm not going to run this full screen because when I use PowerPoint, I use it to make diagrams and they're often bigger than the slides. So I'm going to keep it at this 60% resolution. And what we're doing here is at Web 7.0 is we're creating an actual DID exclusive operating system. And there's a special kind of operating system called a library operating system. So I'm going to take a few minutes just to explain that, just to give it context as to why I think these uniform DIDComm message types are important. So it's going to be a little bit tutorialish to start with. So when you think of a a library operating system, down here at the bottom, these are the traditional host or operating system services you would expect. And a library operating system is something that sits on top of that, and it provides a system of libraries that provide a ecosystem or framework specific set of interfaces, and you never reach down and use the operating system interfaces. So you're always um, calling in from the application layer here through the developer abstraction into these bunch of libraries, which in turn calls through the host abstraction layer down here. This was pioneered in the 1990s. There's a lot of current research going on, for example, to make Windows a library-based operating system. The idea is to make the kernel of the operating system as small as possible and for the library operating system to run in user space. It's um, it's a way of doing a sort of virtualization, like uh, virtualization without having to create an entire virtual machine. So if we go down another step, the next thing you need in your library operating system is a bunch of libraries, and these are intermediate or medium level libraries that support whatever the application framework is that you're trying to do. And so if we think of some of them, I'm still staying generic here, but we need some sort of identity and messaging protocols, some sort of long-term or persistent memory, um, some sort of fast cache for having uh, ready, fast access to different objects and that sort of thing. Maybe an agent framework, and then we need a call interface, a way to call through the host abstraction layer to get at some of these resources down here. So um, we talk about this number two here being the north interface. Um, and that's a term that was started in 1990. Oh, I forget the name of the operating system project right now, but the idea is there's a north face that applications talk to. There's a south face that the library operating system calls through. And then you optionally can have east and west interfaces for things that don't fit in. And I'll show you some things that we're going to put over here on the left-hand side in a moment. Any questions on this kind of concept of a library operating system so far?
Not really a question, just kind of a comparison. This kind of reminds me of Docker and what Google's idea was with Core OS, where you essentially had it was a Linux distribution that ran Docker. You couldn't SSH into the box really. I mean, you could technically, but not practically. So you set up the box, it runs Docker containers, and whenever you want to like spin up applications or have them talk to each other, I mean, it's just a Docker box, but it has that lightweight feel of it, and you're not running like as you mentioned, the kernel's small, it's shared between all of these containers, so you're not running the kernel for each and every single one of your applications in the containers.
Yeah, no, that's a valid comment. There's probably six different dimensions to this discussion, which would be a whole different talk. So it's similar from a containerization perspective. Where this would differ from Docker is that Docker apps that run in Docker still typically call to the host operating system directly. And you could say, well, yeah, but my application has an intermediate layer. This is about formalizing the intermediate application layer as an operating system interface, a higher level operating system interface. But the comparison with Docker and a number of other virtualization strategies is the same. Um, I'd introduced kind of the West interface here, and I've put the actual creation of messages, message payloads, relationships, trust libraries on the side. And the other thing I've introduced is on the right-hand side, solution builders build the purple boxes, host um, builders or operating system builders build the items below the south interface. And then in the case of um, the Web 7.0 DIDLibOS, it's the Web 7.0 Foundation, governance council that kind of owns and manages this stuff. So as I was looking through this, I said, okay, these are core. These are really, really deep core things that I have to have. And these things I have to have as well, but these tend to be things that are built on the core items that are in the red box. And there's still some latitude for that to change, but um, if you just go with that as far as this explanation is concerned. So then what I did is we're getting serious now about this DID exclusive decentralized library operating system. And when I say DID exclusive, I should change this here. DID exclusive, I mean everything is a DID. So for example, I have some statistics later on. If you look in the DIDComm spec, there's 118 references to http://didcom.org for mostly for retrieving schema and stuff. So in the case of Web 7.0, everything is a did. And so that has some implications. And that led to this subject of not just what is a uniform way of defining message types, but what's a uniform way of using DIDs for everything we see in the operating system. So, of course, from the identity perspective, we have identifiers, documents in the DID registry. From a messaging perspective, we've got DIDComm messaging with DIDComm messages. Long-term memory, we actually use DIDComm messages as our serialization uh, for long-term memory, long-term persistence, and I'll explain a little bit more about that. The memory cache, the fast cache, is also DIDComm message based. The switchboard is what listens to the inbound interface. And this is what looks at the incoming messages, looks at the incoming message type, looks at the thread ID, and it decides which one of these modules up at the top that message should be routed to automatically. So it's a general purpose library operating system for running any application, any DIDComm application that conforms to the lib operating system. And then just to kind of emphasize this idea about being did and DIDComm centric, when we're calling functions or methods within the operating system, we're actually using DIDComm messages for that. And you might say, oh, Michael, God, that's way overboard. That's expensive. You're telling me that I've got to verify and decrypt these messages. My answer is yes. And the reason why is because we're using DIDComm messages everywhere for persistence, for the fast cache, for routing, for passing parameters around. If that's the slowest, worst part of the system, that's the one that people are going to focus on and make faster. I'm not worried about that problem not being solved. Um, I'll stop for questions in a minute. On the left side here in the gray, we've got libraries for creating actual DIDComm messages. Verifiable credentials is the default format for payloads, although you could use any JSON format, but we lean heavily towards verifiable credentials. Trust relationships, we've got a concept of verifiable trust circles, which is based on multi-proof verifiable credentials. And then I stuck the trust libraries down here. These are just our standard libraries for doing hashing, signing, verification, encryption, and decryption. You could say they could be down below the hardware or below the host abstraction layer. Um, what I've chosen to do is put them here because they're under the governance council in terms of these particular libraries. And I probably should have like a 7.5 over here, which is actually the operating system encryption library. So that's a change that's a change I'll make later. I'm just gonna copy and paste this over here to remind me. So so this is DIDLibOS. This is a platform, a global platform for running arbitrarily complex networks of DIDComm agents. Now that's a bit of a mouthful. Anybody have any questions about that? Oh, come on, guys.
One question that I do have, I'll speak up here. One question that I do have in relation to how everything's being handled in with DIDComm messages here,
Yeah.
is part of the idea that if an applicate like so we're talking about DIDComm messages being used for inter-process communication on the same box potentially. Um,
No, globally as well as in the same box.
I was going to get to that. So if, for example, I wrote an application, instead of writing DIDComm's, stuff within my own application, could I forward that off through the quote unquote IPC messaging portion here and have that end up going to a different box on the internet?
Yes,
Okay, that's
absolutely.
kind of neat.
So let me go into this one. I put it in there, wasn't sure if I was going to use it, but this is what a Web 7.0 agent looks like. Um, so we have DIDComm messaging here. I just called it version 7.3 because there's a series of these. And you see that it runs on top of REST over DIDTP. You may remember in one of our conversations, I brought up this concept of zero tier, which is a wide area virtual network software solution. What's cool about that is I dug into it, and it's an open source solution, is internally it uses 64-bit device IDs, and each device ID has its own public-private key pair for uh, encrypting the packets that are sent over the virtual network. And it's somewhat incidental that the API for this virtual network is IP based or socket based. So we've done quite a bit of investigation and we believe that we can take the zero tier guts and actually put DIDs on top of it instead of IPs. Remember, a virtual IP network is IPs on top of IPs. IPs, virtual IPs on top of physical IPs. So what we're going to do is use DIDComm addresses on top of the physical IPs um, that you get from your router. So we're actually talking about a, a DID version of the Internet Global Communications Network and being able to send DIDComm over that network. So that's the networking side, the purple and the yellow boxes. Here, we've been looking at different ways of creating a programmable DIDComm agent, some sort of scriptable agent. And I happened to stumble across PowerShell a few years ago. And PowerShell, almost in and of itself, you might be familiar with it. It's used for doing administration activities on Windows systems, Linux systems, and iOS systems. It's cross-platform, it's open source for Microsoft, and it is literally like an operating system. You can create what are called run space pools, which are run spaces, and each one of these is an execution area. You can import modules into a run space, and a module is a set of commands, commandlets. And so this could be a run space that implements a purchasing process, or this could be one that implements a systems administration process, or this one could be a request for quotation type of process. These can be actual workflows that can be either scripted or programs. And so this is the heart of our digital agents. And so if I use it, maybe some of you guys have a little more of a Unix background. If you think of like the bash or the corn shell or whatever, and you put a DIDComm endpoint on top of it, that's what I'm doing here. I'm taking a very rich execution environment, multi-platform, multi-OS, and we're putting a DIDComm thing on the front of it. And the last box here is the blue box. These are called lobes because initially we were modeling the trusted digital assistant as a brain. And a brain has lobes, and each lobe is responsible for different cognitive functions. So I went into ChatGPT and I said, using LOBE, come up with a phrase that is useful in the context of Web 7.0. And it came up with the idea of loadable object brain extensions. And so these are implemented as PowerShell modules that can be dynamically loaded whenever a command is issued that refers to or that's implemented by one of those modules. So we've got just an incredible environment for building digital agents. Any questions on that?
So when you were talking about the whole interdid net, is that I'm just trying to wrap my head around this portion here. Is that similar to like kind of replacing the TCP/IP stack, but you're actually just sitting on top of it? But as far as like applications are concerned, it's in a sense replacing it.
It's replacing raw sockets with the DID interface, yes.
Okay.
Or you can think of it as a parallel to DID or to raw sockets that understands DIDs.
Okay. That's pretty cool, actually. Thank you.
Yeah, and I'm actually you guys know Daniel Harding. Daniel and I are talking about this on Friday. But that would be very cool because a lot of the stuff that the group has been working on with relay agents and all that kind of stuff, that belongs down here in the network. So just the same way that TCP/IP relays and buffers and provides reliable communications for packets, the inter-DIDnet is going to do the same thing for DIDComm messages. So we no longer have to have relays and stuff that we build at the user level. Um, okay, so this is just context so far. I'm going to show one more slide. It's just kind of context. So when I kind of sketched out a few sample applications. So what would email look like? What would the protocol look like? We're going to store it in long-term memory. What would the did for the long-term memory look like? There'd be collections of messages in long-term memory. How would we didify those? Um, Here's a purchasing application, inbound purchase orders, outbound purchase orders, that kind of stuff. What would, if we wanted to didify, what would that look like? Presence, notifications, calendaring. Um, this is where I really kind of started and just iterate, trying to figure out how do I bring the did spec together? How do I bring the DIDComm spec together? How do I bring kind of some of the PowerShell attributes together, the naming conventions, etc. The one app that I haven't talked about, this is the Switchboard app, and this is the one that listens to the inbound interface. So it takes all the messages and it stores them in this messages collection. And as well as any outbound messages. And I know it's all kind of cryptic, but where it says MSG, that's a real message. That's a copy of a message. And down here, these are stubs. You notice all the apps use stubs. One of the cool things about PowerShell is you can chain commandlets together just visually or syntactically the same as you do in a Unix shell. In a Unix shell, um, what's written to stood out and what's read on stood in, for all intents and purposes, is always text. What's really cool about PowerShell is when you've got um, an object that you're passing from one commandlet to the next, it's all running within this single run space. And so what PowerShell does is persist one copy of that object, and all it does is pass the handle from the first commandlet to the second commandlet to the third commandlet to the fourth commandlet. So the efficiency, there's no copying or serialization or deserialization of objects from one commandlet to another. So we use that in in our storage model by storing one instance of the messages on a particular client, on a particular trusted digital assistant, and every other app then is just referring to the handle or the stub for the message that's stored over here. So the switchboard is what listens to the inbound interface. It's also we talk about an outbound interface, although that's a little bit abstract. But if if the email app puts something in the outbox, it creates the message over here. It sends the message to the switchboard, puts it in the outbox, and then the switchboard looks at sending that out. So all sending and receiving from inbound and outbound uh, interfaces is done by the switchboard. And it's essentially serving as the archive, etc. Any questions there? I know this is a ton of stuff that's new. All I'm trying to do with this slide is highlight the naming challenges we have from a DID perspective. Okay, what's this one? I'm not going to go into that one. So if we go into the DIDComm spec, if it's supposed to be a DID communication messaging spec, why is HTTP mentioned 118 times? Why is this mentioned 32 times? So just a little poke in the ribs is DIDs are under/misrepresented in the spec. And I'm going to show you a couple examples. So here, when we're defining in the spec, section 9.1, this is DIDComm spec, the protocol identifier URI, there's one lowly DID example here, and it doesn't even conform to the grammar. It's got a semicolon in it, which isn't in the grammar, and it's got a message type or a message name on the end, and message names or message types aren't even part of this part of the spec. So that line is completely wrong.
The
And
semicolon actually is. It's under delimiters.
I will show you it isn't. So if we go to the did specification, the semicolon character can be used according
Oh,
to
I
the
see.
rules, technically, but future versions of the spec may use it for something else. So it's recommended against using it. Sorry that I made you step into that cow pile.
I was looking specifically at that slide which said like delim and had semicolon in that list. So
Yeah, yeah. No, I know. And this is where it gets tricky. And until you really start building stuff, it's really hard. Okay, so here, so this slide is the protocol identifier, the first part of it. Um, the really nice thing I like about what the DIDComm spec does is the didcom.org part that we put in there. I call that the authority. And then this is like the did method, subject to this authority. It's a bit of a mind jump, but I'm going to show you how I make use of that later on. And this completely perverts the did specification, but so be it. So here, now we're adding the message type name after, and here we're using the semicolon. We're past that argument. Um, but I don't think this, like if I try to compare one of these HTTPS ones to the did example, like they don't match up. And like why is this a URL? Why does this look like a URL? And um anyway, we can nitpick, but basically I'm saying that, and these are the only two examples in the entire spec. And then of course there's hundreds of places where HTTP is used to get at the schema, the context thing. Well, if we're building DIDComm, why aren't those did URLs to get at the schema? So here we start to get into some of the solution. So part of this thinking originated like in the W3C side of things and in the WebVH did cell discussions. People are realizing that these did methods are more the same than they are different, or at least they can be componentized or potentially factored. And so I said, why don't I've got a whole other thing that I've done where I said, why, you could actually factor these as interfaces. You could have a base class for a did method, and it could be, derived from a like a blockchain-based repository registry or a web-based registry or um, whatever. And so I actually prototyped it in C sharp and then said, well, if I turn these all into interfaces, then we can actually dynamically build did methods on the fly. A developer, when they need a did method, can just say, I want a new did method, and it's going to inherit these interfaces. And it'll automatically be one that does event history. It'll automatically, go to a blockchain. If later in I want to change it to be web-based, I can do a web-based interface. And that going down that path led me to this idea that we could create an interface description language, a formal language used to describe um, did methods. And I go on and on about that. And then here's some examples. So this is really getting to the title of the talk. And so first of all, I needed DIDs for things. So this is actually my proposal for a uniform DIDComm message type. So the idea is this first thing is the authority. This is the didcom.org. And then I wanted to have a grouping mechanism because there's another spec called the APQC process classification framework, which organizes things into processes that are made up of capabilities that are made up of tasks. And so I wanted to start with a process name and a version, like a sim version, slash a capability, slash or underscore a version, followed by a task name. And I've been iterating on this quite a bit. And so here's an example. So if Web 7.0 is the authority, onboarding is the process. So where this perverts the did specification is onboarding is really like a did method, but it's a did method that's subordinate to this authority. And if we would have done this way back when, this would have solved so many problems with the did registry and all the hokey arguments we've got about did methods because people could just declare themselves an authority and then do whatever they want. So the other thing is I had to figure out a nice pattern for versions, something that would be easily parsed. And so I call these actually sim dash versions. It's the same as the simver that's in the spec, but using dashes instead of dots. And so here's a fully worked example. We have an onboarding process that has an enrollment capability that has a verify email task name. You can do it with or without the version. If you do it without the version, you just get whatever the most recent version is um, of the process and the most recent version of the enrollment capability. So that's going right down to the task level, which is what DIDComm message types are. Um, if you want to just address the capability, because you also want to be able to occasionally ask, okay, ask a capability, what tasks do you perform? This is coming back to the interface description language. Which tasks do you support? And similarly, I might want to go to a process level and say, okay, purchasing process, what capabilities do you support? And this becomes a very rich kind of a DIDComm scenario where I can start asking like a digital agent, what processes do you have? What capabilities do you have? For a given capability, what task does it support? So this goes back, Colton, I think to your earlier question about can this could run tiny little bits of an application on a million different digital agents. Any thoughts?
So, is this like kind of a discover method that you are trying to implement in this language? Like,
You're gonna have to speak up a little bit, Vinay.
yeah, can you hear me now?
Yeah.
So, are you trying to implement something like discover method that is in DIDComm? Because DIDComm already has discover, right? So,
Yeah. So I'm aware that um, DIDComm has discovery built into it. Actually, the next slide, I go into that. So so I've been trying to be faithful as possible in a weak way. Um, but I think you'll see, like, rather than just having query and disclose, I'm also following a pattern um, suggested by PowerShell where you always have verb and a noun. So I've got query capabilities. Oh, maybe this isn't quite right. Query capabilities, and this should be query task, actually.
but wouldn't it make sense to like map the things that we already have to this language instead of like creating new stuff?
Um, I apologize. Can you say that again?
So wouldn't it make sense to like map the already capabilities that are there in DIDComm to this language instead of creating new keywords for it?
That's a fair comment. Um, the the answer is because we're building a greenfield operating system, because we're building from the bottom up, and there's so many little places where we've chosen, not just chosen to differ, but we've felt it important to differ. Um, I haven't been religious about, you know, fake backward compatibility.
To me,
Does
like
that
we
make
have
sense?
also, yeah, it kind of makes sense, but like we also have like certain things going on. So the biggest thing that we have issue with is the strings. So like if you are transporting certain things on like OS level messages, like these are too big. Like we personally use binary notation. So did is just like x01, and like so we reduce the whole thing into just like a small messages, and whenever we are sending over Bluetooth or like certain things that you would see in like the DIDComm protocols we have, uh
Okay.
this is kind of like the same kind of things that like we found as well, because when we are sending a DIDComm message over Bluetooth or something, it's quite huge. Just sending
Yeah.
hi over DIDComm is like it's a huge message. So we had to reduce it and compress it and like do certain things on top of it. So I
I
like the idea of like having a language that can like do all that DIDComm things, and it is like small and like minute, and everybody can use that. But I
right.
don't know like we how we can all be compatible with each other if we are going to use like different naming schemes. Like that's kind
Yeah.
of an issue.
Okay. So you've got two different topics there. I understand your and appreciate your comment on the length. There's just off the top of my head two ways that we could look at addressing that from a Web 7 point perspective. One would be to create an alias so that you could declare if this is something, whatever, like you go back to the send email example. If this is if this is a type you use a lot, you could send an alias type DIDComm message to your agent saying, whenever I give you this short message, expand it to this.
Yeah, this is like exactly like what we are doing currently. So do you have
Yeah,
any code for this? Like have you implemented any OS level code or anything on it?
we have we have working code that implements um, that. Well, it implements everything except for the PowerShell part.
Okay.
And just a minute. And then the second thing I was going to say about what you mentioned was so aliases, and this is just right off the top of my head, you could have the concept of a like a current working directory or a current working process. You could say, I'm going to talk to you, but it's always going to be in the context of this process. So from now on, I'm only going to talk to you about capabilities and tasks. It's kind of like doing a CD to a process, or even doing a CD down to a capability. And then from that point on, you just execute tasks.
Okay, it's quite interesting to me, and I'll be interested if you like open source any code to like look at it.
Oh, well, it is open source. It's just kind of disorganized right now.
Okay.
Um, okay, just we're doing pretty well on time. I've only got one more formal slide left. So here, this is one. These are all kind of piecemeal that I put together. But if you start with the did spec and what it says, and you start with the DIDComm, I was using 1.1, and then you start with PowerShell. PowerShell has um, runtimes. They have runtime pools. Oh, this is just the overall runtime. They have run space pools and run spaces. Um, and then they have modules, and then they have the verb.object naming for tasks. So, like verify email would be a verb object. And so you can run these together and say, did Web 7 onboarding enrollment, verify email. And I mentioned the APQC process classification framework. Well, it nicely breaks down processes, process activities, and tasks. And it all works well. Actually, the did spec is the biggest culprit because they're using the method here as the second component of the did thing. And I really want to use the second component as an authority, right? Or I want to use the first one as authority, not as a did method. I want the did method to really be the second component of the did method. Does that make sense to anybody?
Yeah, it makes sense, but like so it makes sense, but what I'm like uh thinking is like how we can have it like like how can we contribute to it, or how you can contribute to our stuff, like
Yeah,
if
yeah,
not like agreeing on on like the basis of those things. I understand that like whatever you have did web 7 did ajna, like these are the basic methods. Even if you create schema grid def and all those things,
yeah,
like when you do it, like it's there, but having it on the didcom side, like it's kind of like little bit hard for me to like digest and accept the code
yeah,
change.
yeah. And that I recognize that, and that's just kind of the purest approach we felt we had to take to build the best possible thing we could build, right?
Yeah,
And
sure.
and 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 I'm not being facetious here, but backward compatibility or interoperability is not a big consideration right now. We just want to make it work.
Okay.
And that's about all I have to say. So I should have highlighted at the beginning that this isn't a proposal. This is just a conversation and kind of an update on what we're working on. But I think there's a lot of novelty in it. And when you start looking at an application end to end and everywhere, if you're going to be pure did centric or did exclusive, um, it it has implications, and the current specs aren't did centric. And I'll leave it like that. What I will do is I'm gonna put these together somehow, and I will create a YouTube video, and I'll make the link available to everybody so that you can go over this again.
Sure. So like from what I understand, like DIDComm things are DID agnostic. So any DID can implement them. So I have like a personal DID that like DID Ajna that we work with. So we are not doing like, like whatever we are building that, like it should just be on our stuff. We are contributing it back to the DIDComm community, like whatever protocols we are building. And
Right.
those like just being did agnostic, like any did can implement that. Like if you want
Yeah.
those calls to be implemented on Web 7, you can implement it on there.
Yeah. Well, maybe I didn't really highlight it, but if we look at this example here, so this is the process. It's just a grouping, but the process name concatenated with the um, capability name, that's how we're naming the module. That's how we're naming the PowerShell module. And so when this message comes in, the first thing that the trusted digital assistant, the first thing the DIDComm agent is going to look at is, given this process and this capability, have I already preloaded that module? If I've already imported that module, then I just have to execute, verify email. If I haven't already loaded that, I need to go out and possibly download it and possibly import it. So there is a significant bias in this naming convention towards, um, towards what's happening in PowerShell, towards, this column here. I want everything from left to right being sort of one to one, and not to have lookup tables and translation tables and those sorts of things.
Yeah, it's quite interesting. Like uh, let's see like
Yeah.
how like uh things go, and like we would surely be interested at like looking at
Yeah.
it. Quite interesting, and I have faced like these issues myself, so like it would be
Yeah.
interesting to see like some implementations on like how to solve.
Right. Can you send me a link to your project?
Uh, sure. Like we haven't like open sourced everything, but I can share the DIDComm protocols that we currently have.
Yeah, well, just a link or two so I can understand. And maybe there are some, because yeah, we've obviously been very introspective in terms of just looking at Web 7.
Yeah, sure. I'll find you on Discord and I'll drop a
Okay.
message.
Okay. I appreciate everybody's time, and Colton, I appreciate the opportunity, and I hope this is a valuable use of people's time.
Yeah, I thought there were some very interesting, as I mentioned earlier, the idea of DIDComm sitting on top of TCP/IP,
Oh,
where
you like that, do you?
yeah, well, because it turns DIDs into more first-class citizens.
Yeah,
So if you ever want to, communicate with another user or a computer or whatnot, you just do that via their DID and send the DID message. Like,
yeah,
you want to pull up a web page or whatnot, you just plop in the DID and then it ends up resolving to
yeah.
the right server and communicates over DIDComm to retrieve the web page for you. I think
And
that's
we end up with our own completely independent network for running DIDComm applications.
hmm So I think that is like just really, really cool way to think about things.
Okay,
Um,
okay. Well, I I'll confess I use ChatGPT a lot to help me. It's almost like a coworker. Often I will save conversations on my blog on hyperonomy.com. I'll see if I can find one related to that, Colton, and I'll put it there so people can read up on what it might take.
okay.
ChatGPT figured it would take about 6 man months to make it work. on top of the existing open source repository.
Yeah, but existing open source stuff, like if you see Akapai and CredoTS, you can't
Yeah, so
really.
yeah, we're talking about the zero tier project.
Okay.
So zero tier is a project, a product, and a project and a repo. And the thing that's not part of the repo are like the administration tools for signing people up and stuff. But the whole networking piece that exposes virtual IP addresses on Windows, on Android, on Apple, that's all part of the open source, and that's the piece we would behead and put DIDs on.
So are you using some kind of like decentralized, so like Kademlia or DST or something like that to store the DIDs on the table or what?
Down here,
Yeah, like
um, because we're storing them actually as DIDComm messages, they're trusted and secure to start with, and we're using LightDB
no, I mean
as
like
the
if I have a PC and you have a PC, I have your
yeah.
DID. So if I need to resolve that DID and get to you, how do I resolve that DID?
Well, you'd have to have um, one of us would have to build a lobe. One of us would have to build um, an extension that would essentially provide object access based on an incoming DIDComm message.
Okay, so uh,
We'd have to
I
have like a fetch object and a store object message protocol.
okay, so like basically we also are doing like similar thing, but we are basically building a whole blockchain mesh network on top of DIDComm. And
Yeah,
so we are trying to, connect the whole world as well through DIDComm. So peer to peer, everybody can connect and message and do all those things.
yeah,
So it's quite interesting. Like I'm just like repeating that. It's quite interesting. I'll take a look at it.
yeah. So just a parting note. So everything is written in C sharp. PowerShell for Microsoft is written in C sharp. The LATEDB is, I think it's written in C sharp, but it certainly has a .NET interface. And let me find the picture here before I die. Um,
Well, you're finding that.
all of these modules here, all of these are written in C sharp. We're 100% C sharp over .NET. The whole the whole library OS is written in C sharp, and all the supporting stuff is written in C sharp. And all of these blue things are C sharp. And then we're using JWTs to as really the format for our JSON messages. Or not our JSON message, our DIDComm messages. We try to be 99% compatible, but again, just to be fair, interoperability is kind of low on the list. So there are some little nuances where we wouldn't be compatible on the wire.
So I do realize that we are getting close to the hour, and I know that Steve, you joined partway through. I was just curious if you had any thoughts based on what's been said here that you've seen since you're on the or since you are part of the working group.
Oh, thanks. Yeah, had a conflict earlier in the hour. Um, no, it's interesting. I noticed on the one slide the DIDComm messaging here was up to version 7 point something or other.
That's because this diagram is part of a roadmap, and I've just labeled the different versions 7.1, 7.2, 7.3. It's arbitrary.
So
The
is that a
7.3,
different standard than what we're building here?
well, this is the one that would run over DID directly on the interdidnet.
I believe it, as mentioned, it's an arbitrary number, but based off of Web 7.0.
Yeah. Yeah, it's just a placeholder. But so it's based on the spec, but it's derived. It's classic embrace and extend philosophy.
So, just to understand, is it the same current DIDComm spec or is it different? And I guess I ask because the
It's not
number would lead
compatible.
me to think it's
Yeah,
different.
it's not compatible. It's not wire compatible.
Okay.
It's inspired by the spec, but not compatible.
Okay. That that could be confusing if it's not the same spec. Um, I'd probably pick a different name or, you know, somehow reference it being modified.
Yeah, well, we call it DIDComm plus plus.
I don't know what
We'll
that is
figure
either,
something out.
sorry.
Well, no, it's just a different name. Yeah. Okay, well, if you want to follow up, Steve, I can present this to you personally if you want, or you could wait for the recording.
Yeah, it's recorded, so I can check that out. Thank you for presenting.
Well, I
Hmm.
really appreciate everybody's time. It's kind of the first big public uh, entree, so we'll see what happens.
Yeah, I'm excited because you mentioned that this is more of a conversation starter, right? In a sense, and so
Yeah,
it's neat to see what others are thinking about and how DIDComm could be used, and that's pretty exciting. So thank you very much for offering to present and presenting today. And
thank you. Thank you too.
with
Okay,
that
and feel
being,
free to reach out. I do this basically 110% of my time, so if anybody's interested in reaching out, please do.
all right. Thank you everyone for. Wait, Vinay, did you have a comment real quick before we close?
Yeah. Yeah, just like a quick comment, I updated some of the mesh network DIDComm protocol that is there, and I created a new PR for Ledger's protocol. And I wanted to say like the WebRTC stuff is like stuck there for like November. So I think like we should merge it, like the implementations are there now. And I have like contributed those like implementation into Open Wallet Foundation as well, like with our new project. So I think like we should merge the WebRTC stuff, and probably in the next meeting I can talk like something about the new PR that I made.
Okay, I will take a look at those after this meeting and see about getting that merged.
Cool. Thanks.
All right. Thank you everyone for coming today and great presentation. I'll see you all next week.
See you.
Ta-da!